As a developer, you may have heard about this input validation, that you need to check your inputs. But you may wonder why and what's the big deal, right? So in this example, we have a web app made in Python. This is a Flask app, but the same principle applies to any Python web app. Here we have a simple input field, and using this input field, we'll control the whole server below it. So here we have a field where we type the IP address or the network address, any website name, and this ping command, it checks for connectivity, right? Pretty simple. So for example, we could check this internet address and see, do we have connectivity? So it takes a second to load and you'll see, yes, there is connectivity. This could be any website as well. Let's say youtube.com, where we have this video, and you'll see there's connectivity. So obviously this program runs by using the ping command below. However, there is no input validation in this program. Now, you might know or might see here that this might be running Linux underneath. So what we can do on Linux is chain commands. You can do that with a semicolon. So you can say command, semicolon, and so on. So for example, we could say some address here, semicolon, and then run the date command and see if there's no input validation. It should run that command. So if I run ping here, you'll see it takes a second to load, and then it will give us the date here. Not too spectacular, but we can do more things. For example, we can run the commands who am I, we can get which current user it is being run as. Now you'll see it is a bit slower because we are using the ping command that takes some time to execute, but we can see here which user we are. Now there might be more interesting things we can do, right? For example, we might want to read the etc password file. So we do cat/etc passwords, and we can then see the file etc passwords contents, and there we go. Now we know all the users of the system. Now, if it is running unsecured, we might also get the shadow file and get the actual passwords in hashed form on the computer. So we can do 8888 or any whatever. Semicolon, that is the key here, so they don't filter on the semicolon input. And then we say cat etc shadow and see if we can open that. So in the best case, it is blocked by the user protection. So that's what we have here, permission denied. In the worst case, the attacker could then view your passwords on your current system and any other configuration files on your system, right? So they can now run files on your computer. And this isn't just limited to running commands. They could actually get terminal into this computer and directly have terminal access as the user Ubuntu into your computer, just because of there's one little input box here that is not doing the right input validation. So one little mistake and a hacker or an attacker could take over the entire web server of the computer. So this vulnerability, it is not limited to just reading files on the computer. They can actually get access into the Linux server or into the server running the Python application using this method. So for example, in here, what we will do is a reverse shell. So this victims or this web application, the server will connect to our computer and provide a shell. To do that, of course, we will check which IP address do we have. So in this case, this is our IP address. Of course, it depends on which network setup. So what it will do is a reverse shell. It will start a listener. So the hacker might do this. Then here they can type any command. It doesn't matter. Let's say pwd. And then they run a reverse shell command. So that connects their Linux computer, the server below, to the attacker here and give them a shell. So of course, for that, they need to connect to the right address and port. In this case, we open port 4444 with the IP address. And then if we run it, you'll see there's a syntax error. So those things can happen in reality as well. Let's say we try again. And you'll see there's a double semicolon here. So let's check the command that we don't have a double semicolon. So let's say we run some ls command. And then let's run it again. I'm not seeing. There we go. Now we got a terminal into the Linux server that was just a simple input field. Now if I check the UMI, you can see we have the Ubuntu computer, or I check the machine information and we see we have access into this server computer. And we could browse around, right? So we can check, okay, what is in here. So obviously some things, some example things that played around with. And then we can see, okay, we are inside the Linux computer and we can read this password file. And a hacker or attacker might then try to become another user or simply try to become the administrator using other tricks. So all of this is possible simply because of an input field that didn't check for a semicolon missing, or in this case, allowing a semicolon, which allows for chaining commands, right? So on Linux, you can chain the commands like this, and then they will be executed after another. So if you block invalid input, in this case a semicolon, the hacker wouldn't even have initial access into the server. So this is a common mistake many developers make with input validation. In this case, it's a simple ping program, but it could be any kind of input validation that then gives hackers access into the server. So here we have the source code of this simple Python Flask application. It's simply, if we look down, you'll see there's an index function that waits for input, and then there's a route ping. So this ping command, it simply runs the command ping on the system with the parameter target host. So you'll see, and then you subprocess to run that application. You'll see here subprocess.run, and it runs the command, which is the command ping with target host. So quite simple application. Simply whatever input is given as target host, it will ping that command and then return that here. You see, return the output. So the command's output is simply returned. So it simply uses the ping command, which checks for connectivity. Pretty simple, and you would think, okay, what can go wrong with such a simple application? So here, what an attacker might do, of course, is try to manipulate this target host and then try to gain access into your computer, read files, gain a reverse shell, and more, which I'll demonstrate in the rest of this video. Now, if you take a look at this route here, you'll see app.route. This is a route in Flask where if you call this web link with a GET request, so if you just type it in your browser and press enter, what it will do is run the command. So the button press that you saw before, when you type some address, it is linked here, and it then gets the target host from the browser parameters, and then it uses that target host in there. So what you want to do for this to work is to filter this target host. For example, if the semicolon appears in here, it should break the request completely. For example, we could say if semicolon in target host, then we could return none, because there should never be a semicolon, because that means someone is trying to run commands. So if we save this and restart the server, then we should be able to run. So let's say we kill this server, and let's say we open this here and we restart the server. Now, when we open the browser and we try the same command and with the semicolon, it should then break from there, because if there's a semicolon, it should just return none. So let's see what happens. It could be an internal server error or some other thing, but let's take a look. So the default command, let's try some address here, let's say youtube.com. That should run fine, right? Because there's no semicolon in there, so the behavior should be the same, and you see that run fine. Now let's try this attack again, but then let's see if our little fix solves the whole problem. So we do add a semicolon here, and let's say some commands, and we click ping, and now we get this internal server error. So it's now blocking that. Now this is a very simple example of input validation, and of course you'd want to solve other cases as well, because this is not the only way an attacker might play around, right? So they might not just do semicolon. There are other tricks with Linux to run multiple commands. So this wouldn't be enough to stop all the attacks. For example, what we could do here is we could add an ampersand instead of a semicolon and see what happens. So we run the ping command again, and you'll see it takes a second to run, and you see it still run the command. So just filtering on a semicolon alone is not enough. You want a complete filter of your input for any invalid inputs, because hackers will try all of the inputs to gain access into your computer. For example, let's say they type some address here, ampersand, and then pwd, and you'll see if we run it, the hacker will see these inputs and they say, okay, we are in the user home Ubuntu. And with the same method, they could get a reverse shell into the computer and then do privilege escalation and become the root user on your server, just for wrong input validation. So you have to keep in mind that it's not as simple as simply checking one invalid input, for example, only filtering on a semicolon, because there are other tricks, other invalid inputs. You want to capture all of them to prevent this kind of attacks in your Python program. And the whole vulnerability started for this little simple input box.